Hi, welcome to the lectures on IPv6. This chapter has about, I think, 8 different sections. I'm not sure I'm going to do 8 videos, so we'll see what goes on. So the question is, why would I want to take this module? Well, guess what? After you learned all how to subnet in IPv4 and struggled with that, and IPv6 does away with a lot of that stuff, and at least subnetting in IPv6 is a whole lot easier. But we'll see. You'll see. I know. Trust me. I know. Easier said than done, right? So what are we going to learn in this module? Basically, you're going to look at why. Why do I need IPv6? We'll look at some of the IPv4 issues, some of that will be a repeat. Then we'll look at how an IPv6 address is represented. We'll look at the different types of IPv6 addresses. Then we'll look at how to configure a global unicast address and a link local address. And we'll get into some of that. Then we'll look at some of the dynamic addressing for the global unicast and then link local. And then, of course, as we had with IPv4, there is in multicast. There are some routing protocols that need to share information back and forth, which you'll need a multicast. And then, of course, the last but probably the easiest thing to do is how to subnet in an IPv6 environment. So let's look at IPv4 issues. Now, the question is, why do I need, IPv6? You already know that IPv4 is totally run out of addresses. The last one that can be publicly transmitted has been assigned. Can't remember the exact date, probably back in 2012, 2014. So it's been a while. So we needed a new system that allowed to publicly locate or route packets on the internet, and they came with a new version, IPv6. Now, it is a larger address. It's 128-bit versus 32. So it gives you 2 to the 128, which is 340 unidecillion addresses, which is what? 340, followed by 36 zeros. So it is a lot of addresses. But when it started to look at the successor, we needed to look at a lot of different areas here. So it gives you a rough idea when things expire. Well, okay, it looks like North America it was 2015, but you can tell in Europe it was 2012. Africa was 2020, they're projected. Latin America was 2011. So worldwide, IPv4 addresses are running out of space. And granted, as we learned last week or two ago, network address translation had definitely extended the life of IPv4, giving you public and private addressing. But even network address translation is problematic and does cause its own little set of headaches. But just knowing that the addresses are running out, we want to get rid of network address translation with the advent of Internet of Things. All of this stuff is ways that we need to start phasing out IPv4 and start doing increase and use IPv6. Now, can the two work together? The answer is yes. There is no scheduled date to be totally to IPv6. So IPv4 and IPv6 will coexist for the near future. And it may take several years for this to come to being. I've been teaching this class for over 10 years, and guess what? I've been saying that for all of 10 years. So there are definitely different ways of letting these two exist. There are 3 that are popular. One, you got the dual stack. Dual stack allows both IPv4 and IPv6 to coexist on the same network segment. If you check the IP address for your laptop, you will find an IPv4 and an IPv6 address. So when you get to that network interface card and you check on properties, most of them will have addresses assigned to both, or the DHCP is assigned address to both. So basically dual stack says I'm running both stacks simultaneously. So it has both of them running and all the time. Now, if I wanted to look at tunneling, now tunneling is where I can transport an IPv6 packet over an IPv4 only network. So you've got dual stack, you got a network that's IPv6 only, but you got a router that's dual stack. And what it does is take that IPv6 address, puts it into an IPv4 network, and then on the receiving end, the dual stack, then what? I strip off the IPv4 and I've got just the IPv6 address. So it's basically encapsulating an IPv6 data inside an IPv4 packet. And then the last one that we can go through is a translation. Similar to network address translation, but this was network and translation 64, or NET 64, which allows an IPv6 enabled devices to communicate with IPv4 devices by using a translation similar to NET that we use for IPv4, where an IPv6 packet is translated to an IPv4 packet and then translated back to an IPv6. So you can kind of go back and forth to an IPv6 only, IPv4 network only, and then translate them back using a NET 64 router. Tunneling and translations are, transitioning from native IPv6 and should only be used, where needed. So basically what we're seeing is that dual stack is probably the way most environments are set up, where they're running both at the same time. So that's kind of where you want to try to get to as quickly as you can. So unless you don't check your understanding with IPv6, and then I'll create the next video on how an IPv6 address is addressed, or how it's represented.